In this video, I will be going to discuss about one of the sorting technique which is known as cycle sort algorithm. It takes big of n square time complexity in worst case and best case scenario. It is in place algorithm, means it doesn't take any extra space to sort the array elements. It takes only the space which is required for that particular array elements. It is not stable, means if there are copied elements or duplicate elements, then they get a random index at the time of sorting, and it does minimum memory writes. It requires less memory writes because the cycle sort algorithm works on cycle principle, means at each pass the only one element is fixed at its original position and other elements are placed as it is. Unlike selection sort, we don't like to swap the elements at every pass. So that's why swap also minimum in this case. And also, if you have EEPROM, then it is very costly to write at every time. So in that case also, cycle sort is very useful. In interview, like question are there to put in front of you that in cycle sort algorithm, if you have a separate ROM which is EEPROM, then which algorithm you priority wise write on the system. So that's answer is cycle sort because it takes a less minimum writes. So in array, I here take 2 4 5 and 3 elements. I start with position 0 because an index is 0 starting with, then item is 2. I store my first index element into item, that is 2, and I compare with other forwarded elements with 2, and like there are only one element which is less than 2, so I just fix my element into index 1. So as you see now 2 is fixed in its position. Then we fix into the position of 4. So our next item will be 4 because we take that element's position, because 4 is placed in index 1. We take that index and put it our 2 element into that index. So in this algorithm we take 4 as our item. We again check how many elements are less than 4. We again iteratively go through the array and we check that how many elements are less than that 4. So how many index are passing through that, we just go to that index and put our 4 over there. Means at each pass we put our element into its original position. Now 4 is fixed in its position. In position 2 item 5 is we take because we put our 4 element in place of 5. 5 is already there, so we have to take care about that. Likewise, cycle sort algorithm cyclically create one cycle, and at each cycle it places one element at its correct position. That's it. So in position 3, in position 4, likewise, like in insertion sort and selection sort, if there are 5 elements we take 4 pass, n minus 1 pass. So that's it. So let's try to code this stuff. So I here taking return function as void because we didn't go into any recursive call. We just go normally like iterative solution. And also one thing, it is not I code here and that code is not for the duplicate elements. For example, if there are 2 times 3 or 2 times 20, then it create problems. So it's we have to take care about that, like to don't take a duplicate elements. So void cycle sort, we have to take array and integer. So in first case, in starting point we have to assign one cycle start, that is our variable, integer variable, which tells us about how many passes are required and from where we started actually. So that's why I have to take here for loop which is started from 0 and it is less than n minus 1. This is a first task of this cycle sort. We have to pass through the elements. Then we have to, as you saw above, we create pos variable and item variable to store the index and item respectively. So we have to store our CS index array element. Also we have to store that index to the position variable. Why, I will tell you later in the dry run format. So again we have to take one for loop, because we take array of cycle start element, that is in this case 2. We store that 2 into item, and our CS is 0. CS is 0 means our position is 0. So we have to start from 1 onwards, because our first element is always sorted, as there is no comparison for first element. So here we start with CS plus 1, I less than n, I plus plus. Here we have to compare that array of I means the elements which we currently hold is less than the item. Item means our starting cycle element, which is 2. So if 4 is less than 2, which is not possible, then automatically it will swap the element, which is 2 will come first and then 4. So that's how the algorithm works. So we have to increment our position, that's the index, and after that we have to swap array of position with item. That's it. This is first iteration. First half of the code, not first iteration. All the iterations are coming to the cycle start. So what we did here, we just increment our cycle start for each element, and we store that cycle start element into item. We store index into position variable. Then we start a loop from CS plus 1, that is one index forward, and then go up till end, and compare each element with the cycle start element. And how many index we go further, we have to count that. That's why I use here position, and how many indexes we go further, and at what index we find the position of that current element, we have to store our cycle start element into that position index. Then here cycle come into the picture. Up till now you can see that the half of code is very similar to the selection sort, because it is very similar type of arrangement we are follow. In selection sort also we increment our index minimum is equal to j, means from 1 to up till end. Likewise we also do it here, but instead of comparing each time, we have to just compare position incrementation with the cycle start. So if position not equal to cycle start, and also to continue the to continue the while loop, we have to equal that position to the cycle start. Means at each incrementation, our first index is our position, because we have to start from that position onwards. Because before that position, all the elements are already sorted, because in first half of code we take care about that. That's why I write here position is equal to CS. And after that, same code we have to write. Int I is equal to CS plus 1, I less than n, I plus plus. Then again the same condition, array of position less than item, then position increment, and after that swap the position with item. That's it, code is ready. If you see carefully, in first half we just go iteratively through the array. We start with the cycle start element, that is first 0 index. We put that in element into our item, and then we start the array from 1 index onward further. And after comparing that item with the each element, we increment how many time we have to go further, and that will be stored in the position variable, and that position variable we again swap with the item. Like here in second pass there are two times 2. That means we kept our 2 into fourth position, sorry, 4 element position, and 4 is on the first position. Likewise half code is done this work, and after that cycle will created, and that's it. So we have to check our array elements 2 4 5 and 3, 2 4 4 5 and 3. So cycle sort array comma 5, because there are 5 elements. Then to see elements we have to start from the that's it. Code is ready, so we can run the code. So little error here, instead of I write here pause. That's why it's showing the error. Now look to the output terminal. So that's it. As you see on the screen, 1 2 3 4 5 elements are sorted. We give output as 2 4 5 and 3, and we get sorted array with time complexity big of n square. Thank you. Stay blessed.